能听得到吗？等会儿，喂喂喂，现在听得到吗？OK，training will start 6 minutes later. Okay, hello everyone. This is Jim. Can you hear my voice and see my screen? Okay, and the voice is clear. Okay, so okay, let's start. So today I will introduce these parts, program flow of our 3V and 5V. And during the training, if you have any questions, you can directly send here. And I and my colleague will answer it. Okay, question. So this is our mainly contents. These 4 instructions. I will introduce them one by one and use a program to show how it works. So let's check this first instruction. CJ instruction. This instruction is used to do the program job. How to understand? We can directly check this picture. Here, here, when we set on this x0, then the program will directly jump to this point. So it means this part will be jumped. So PLC will not run this part code. Okay. And this is how this CJ instruction works. So you can see here, after CJ instruction, we need to set a device P and with its number P0 and here P0. This is another program dropped to point P1 like this. And here for difference PLC have different range of our P. 3V1S is from P0 to P63, and this is 2N, 3P and 5. 5 series we support from P0 to P4095. Okay, I think this instruction is easy to understand. And now we can check this program. Let me download it. Okay, so here, this line we will set D0 as 1. Okay, here, set it as 1 to close. So now our D0 is 1. And now if I set on this M1, then program will jump from here, from this point to here. So this one will run to be set as this D0 will be set as 2. Link. Wait. Sorry, this program, not later one. Download. Here, check again. First, we set D0 as 1. Okay. And here, when we set on M2, how to set P0? Directly click here on the left side of our program. We can directly set P here. Okay. Yes. Okay, and here we set K2 to D0. So now program D0 is 2. And here if we jumped execute this instruction, then this line will be dropped. So here, if we set this again, we can see D0 will change to 1 because this line is not executed. And also, when we set on this one, D0 will be set as 3. And here, if we run this M3, program will jump from P1 to from here to P1. So this line will be jumped. So here we can see now we can change D0 to 1 again. So for now, the program like this, these parts will be jumped, and also these parts will be jumped. So PLC only runs first two line and the last line. Okay, this is CJ instructions. Do you have any questions about this instruction? Okay, continue. And next instruction is call instruction. This instruction is used to call our subroutine. Bounce 3V and 5V support subroutine. And also bounce into PLC, we use call instructions to call our subroutine. And also for 3V, 3 series, we also use P device to set our subroutine. But 5V is different. I will show the difference later. By the way, I want to say for CJ instructions, the usage of 3V and 5V is same. So here I didn't use 3V to 5V to show it. Okay, continue here. This is our demo program. I think we can directly check this one. Download it first. Okay, so here we can see here we have a code P0 and use M1 to run this instruction. So it means when we set on M1, then this P0 will be run, will be executed, yes. And here we have code P1, and this is our subroutine P1. So when we set on M2, this part, subroutine P1 will be executed. Okay. And here we can see, here we have a FBND, this line. What's this line used for? This line is used to, this line, we need to set this between our main program and the subroutine program. We can see the code, PLC code behind the PLC code above of this instruction is our main program, and below is our subroutine. So we need to add the list between main program and the subroutine. And for each subroutine, we can see here we have a SRET. This instruction. This instruction is you can understand it as an end mark of our subroutine. So this means P0 subroutine is only from here to here. And the subroutine P1 is only from this line to here. Okay. So this is the how to set code instruction. Okay, and here internal monitoring modes. And the first we set D0 as 1. And because we didn't call this to instruction, so this part didn't run now. And if we set on M1, now we are calling subroutine P0. So these two codes will be wrong, will be executed. So we can see D0 is be set as 2. And also, here if we set on M2, then these two lines will be wrong. So we will see D0 will be set as 3. Yes, it's now 3. Can I change P0 subroutine name? 5 can't, 3 can't change the subroutine name. We can only use these points, points P, P1, P0, P2, P3. And then the range you can, and then the range is here. Here you can see both are 3 series. 3V range from P0 to 63. This is how subroutine works in 3V series. Do you have any questions? First, I want to say is this one. After main program finishes, we need to add one FEND instruction. This is one point need to remember. And the second point is when one subroutine finishes, we need to add one SRET. And yes, if without these two, this and this program will report an error. Okay, now I will show how subroutine works in 5 series. Here, in the project management, here we can see a subroutine button and the right click, add new. So here we can set the subroutine name. For example, you can call it text1. Okay, and this is our main program, and this one, right side is our subroutine. So we can add it here. And in our main program, we can also use call instruction to call our subroutine. And here we need to set the name of our subroutine like this. So it's a little difference between 3V and 5V. In 5V, we don't need to set P0, P1. We can directly rename our subroutine and call it in main program. Okay. And this is call instruction, how it works. And do you have any question? Okay, now continue. Yes. And the next part is this instruction, EI and DI instruction. These two instruction is used for used for this or interprets program. Here, EI means enable interloop, and the DI means disable interloop. So this is how these two instruction means. And when we want to run, when we want to program, we want to write interloop program, we need this. Also add this IRET in 3 series. This means return interloop. So we can check here this picture. After a program in our 3V programs, after EI instructions, then this part is means enable interloop. So when program is running, here is running in this part, this range, where there are some interloops be executed, the program will directly to run the interlooped instruction, interlooped program. And when the interlooped program finishes, the PLC will return to the points where we jump to our interlooped instruction. Yes, and the DI means disable interloop. So after instruction DI, this part PLC will not have no response of our interlooped signal. Okay, so usually we need to add this EI. Usually we add this EI instruction in the first line of our PLC code. And for interloops, both 3V and 5V have 3 types of interloops. First type is external signal to trigger. For example, our high-speed inputs X1, X0, X2. And the second type is timer interloops. Timer interloops means this interrupt program will cyclically executed after PLC change to run status. And the last type, we call it as high-speed interloops. It's a high-speed compare. We have a high-speed compare instruction. And when the compare value is same with our counting value, then the interrupt program will be executed. This is 3 types. We can check this first type is external signal input interrupt program. Yes. So here we can see for different X terminal, we will have different device I to set the set the interrupt program mark, just like the P device. Let's have for external input, we have rising edge and flowing edge. And also for each terminal, we will have a system instruction to enable or disable it. Okay, we can check the program directly. This one. Hi, welcome to training. Okay, download the program first. Okay. So first, you can see here in the first line, I add this EI instruction. So when program is running, here, it's running in this area, this range. PLC will have response to our interlooped signal. And first, first I want to say in PLC hardware valuing, I connect Y0. I connect Y0 to X0 and X1. So here you can see when I set on M0 to output Y0, X0 and we're on device. X0 and X1 were on because I valuing like this. Okay, so here we can see here we also have a FAND instruction. This instruction is same with what we introduced just now. When the main program finishes, we need to add one FAND instruction. And here we have 1, 2, 3, three type interlooped program. This is our interlooped program 1, and this is our second interlooped program, and this is the last interlooped program. So you can see when the interlooped program finishes, we need to add one IRET to end this interlooped, just like the SRET in our subroutine. Okay. And first we check this checklist I1. We can see I1 means this one. This means X0 and the rising edge interlooped. So every time when X0 change from 0 to 1, this part, INC. INC means at 1. Yes. Safe at 1 to D0. So it means every time when X0 change from 0 to 1, D0 will add 1. We can check. But now it didn't change. Do you know why? Because here we have this DI instruction. So after DI, this part didn't detect the interlooped signal. So here we set on this M3 to jump to P0. So this line will not be executed. So it means all the program is enable interlooped. And check again. Now we can see every time when PLC gets the rising edge of X0, D0 will add 1. Okay. And here have one point need to be careful. Let me check. Okay, here didn't write. I want to say is we can't use I1 and I0 at the same time. And also we can't use I101 and I100 at the same time. It means in the PLC program, we can only use rising edge or falling edge. One of them can't use these two at the same time for each X terminal. Okay. And the second, this is first type. In program I use this one, and for other is same. Other is same. You can test it when you have time. And also here, this M8050. This is used to disable the interloops of X0. You can see now it works normally. And if we set on this disable this X0 interloops, we can see now it don't work. And not work again. Okay. Okay, I think we can continue for next parts. This type is timing interloops. It means this the mark is like this. I also use I6, I7, and I8. And after this, we need to set an time. The range is from 1 to 99. Yes. For example, if we set as I6 and 05, it means this timer interloops program will be executed every 5 ms. And here in program I use this I610. So it means this part, these two lines will be executed every 10 ms after PLC change from stop to run status. So we can set M4 to check it. You can see now D1 will always at 1 every 10 ms. And if we set it as 99, it will be like this. It's about at 10 every second. Okay. This is how our timer interloops works. This one is easy. Okay. And also we have this M bits to disable it. But here I will not show it again. And this is how timing interlooped program works. Next part is high-speed counting interloops. And the input number is like this: I0 10, I0 20, 30, 40, 50, and 60. And for this six mark, we have only one bit address to disable all of them. And here, back to our program. This one is our high-speed counter. I think D1 have introduced it yesterday. So anybody knows what's this counter? I mean, when we use this counter, which X terminal should we connect? X0, X1, or X2? C236. X1, yes. This is X1 input. So I said I connect Y0 to X1 and X0. And now we can see when we set on Y0, the counting value of this counter will add 1 at 1. And here, for this instruction, DHSCS, it means high-speed counter set. HSCS, high-speed counter set. And the K5 is our compare value. And this is our counting value. And the last parameter is our interlooped program mark, I10. So every time when the value of C236 change from 4 to 5 or change from 6 to 5, then this instruction, this high-speed interlooped program will be executed one time. Okay. Okay, let's try it. First, we set this as 0. And now 1, 2, 3, 4. Okay, here when we set on x2 again, this part will be executed. So we will see D1 will be set as 0. Let's try it. Set again. We can see D1 will be set as will be reset because this part will be executed. And we can try again. 1, 2, 3, 4. From 4 to 5. We can see it's being clear again. So this is our high-speed counter usage of our interlooped program. Do you have any questions about this part? This is how to use interlooped program in 3 series. We need to use EI to enable interloop, and DI is used for disable interloop. And for each interlooped program, we need to use IRET to end it. Also, after main program finishes, we need to add one FVND. And for interlooped program, we have 3 types. First type is external signal input. Each terminal will have rising edge and the flowing edge, and the rising edge and the flowing edge can't be used at the same time. And for timing interloops, we can set the time from 1 ms to 99 ms. And the last is our high-speed counter interloops. If you have no questions, we can continue to check how interlooped program works in 5 series. Okay, here, then in project management, here we can see interlooped and right-click to build it. We can also name it. And here, configuration. Here we can see we can set the trigger type of this interlooped program. Then here have 3 types: external, timer, and high-speed counting. For external type, we can select from X0 to X7 because you know our 5V have 8 high-speed input channel. And also we can change rising edge or flowing edge, the trigger type of X terminal. And here is our filter time, and usually we use default value. But here we can see we here have another setting. This priority. Yes, this priority we have 3 level. Level 0, level 1, and level 2. So the smaller, we can check here. Here, the smaller the value, the higher the response priority of the interlooped program. So 0 is the highest priority, and 2 is the lowest priority. How to understand it? For example, if we have two external input signal, x1 and x2, and the hardware we have, for example, we detect these two inputs at the same time, then which input program should be run, should be executed first? It depends on this priority of these two X terminal. And I want if, for example, we have X1 and priority 0, and have another, for example, X2, and also with this 0 priority, like this. And in this situation, if we get X1 and X2 signal at the same time, then this IRQ0 will be executed first. When this finishes, PLC will will continue to run this IRQ1, this interlooped. It will depend on the order of here of we created order here. If they have same priority and have same time to get the trigger signal. And set configuration, and also here we have timer interrupts, and here we can set the time. The unit is 0.1 ms. Okay, and the last way high-speed counting, and here we can set the high-speed counting device. This 8, and here we set the compared value. Compared value just like this one, K5. Okay. Yeah, so this is how to use the interlooped program in 5V. We can see it's more easy, it's more convenient to use, because we just need to configure it in software. Yes, in software, we don't need to write this P0 and P0 and yes, we don't need to, and this IIT, we don't need this. But one thing is same, is this one. We need to set this EI first in our PLC program. This point is same. Okay. Do you have any questions about the interlooped program setting in 5 series? No question. I will continue to introduce our last part for next instruction. Okay. This instruction is used to cyclically run the program. Yes, and we can check the program directly. Will be more easy to understand. for next. First, we can check here. I will create a new one. 0 and 4K3. K3 and here it K3. Oh, sorry. You can directly copy it. Yes, here K4 means the program between this 4 instruction and the next instruction. Here is this part. This part. This part will be executed 4 times. So the program will like this: 1 and 2, 3, 4. After 4 times, then continue to run other parts. This is for next instruction, and we can check this program. This program we can see here have 1, 2, have 4 instruction, and have 3 next instruction. So it means we have 3 loop of this cyclic program. In the first loop is this part. This part, it will be executed 4 times because here we use K4. And for this loop, the program will be executed 3 times because here we use K3. And then the last loop, this loop will be executed 2 times because here we set K2. So we can see this code will run 2 times every cycle, and this part will run 6 times every cycle, and this loop will run 24 times every cycle. We can download and check it. Set M0. Okay, and stop. Here, for D0, we can see the value in D4 will be 4 times bigger than D2. And then the value in D2 will be 3 times bigger than our D0. And here we can check the relationship between D0, D2, and D4 is 3 times relationship and 4 times relationship because of the different loop times. And why this value will increase so fast? Because the program is always cyclically running, and our scanning cycle is very small. So this value will increase very fast. But the relationship between these 3 values is same, always same, 3 times and 4 times. Okay. And for 3 series, we can use 4 levels of next and the for instruction. Here we have already used 3 loops, and it's max to 4 loops. And for 5 series is bigger. The loop time is a little more, is 5 levels. So we can write 5 for instruction and 5 next instruction. And the running is the same. So here I will not show it in 5 series. Okay, and this is for and the next instruction, how to use it. I think this one is also easy to understand. Okay, this is our today's training. This 4 instruction. So do you have any questions about this 4 instruction? You can type in our chatting group. And if there are no questions, our meeting will end 3 minutes later. Okay, if you have no questions, you can leave the meeting. It's okay, and we will also share the meeting video to our group, WeChat group and WhatsApp group.
Thank you. Read on.
Thank you for your time. Okay. See you next week. Goodbye.